evaluate the determinant by expanding by cofactors. So we solve, which means we are finding the determinant. That's the purpose we learned the cofactor in the minor. So with this example, I'm going to use the row 1 because that's the most of the way I solve for the problem. So I put the equal sign here. So I take the first cofactor, which is 2. It's a positive, right? So I write down the positive here, negative here, positive here. So I put down the 2, and then I create the minor. So the minor would be this 4. So we have 2, -1, -2, and a 2. Now we move on to the next cofactor on the row 1, column 2. Row 1, column 2, the cofactor, she has the negative sign. And then I put down the cofactor number 3. Now let me erase here. So with the cofactor 3, the remaining 4 would be 2, -1, 3, and the 2 that turn to the minor when you had the cofactor at 3. Now we move to the next one. It's a +1. This number is 1. Let me erase. So when the cofactor at the location row 1, column 3, we should have the positive sign. So draw the vertical line and horizontal line intersect at 1. That means the remaining 4 will turn to the minor. So 2, 2, 3, and a -2. Now we just do the determinant with 2 by 2. So going down diagonal has 4. 2 to 4 minus -2 multiply -1 is a +2. So it's a +2. Minus 3, negative slope, all right? I said negative slope or going down diagonal. So 2 to 4 minus 3 times -1, you get a -3. Plus 1, multiply 2, multiply -2, you get -4. Then minus, multiply this 2, you get a 6. So we have 2 multiplied by 2, minus 3 multiplied by 7, plus 1 multiplied with -10. So you have the 4 minus 21 minus 10. So the determinant of this 3 by 3 determinant is -27. Sorry, let me say that one more time. So the determinant of this 3 by 3 matrix is -27. So with this number that indicate yes, there's an inverse. There is an inverse. And then you can use the calculate to finding the inverse, or you can do the row operation to finding the inverse. But this information just help us to move on to the next step. Now we move on to understand and use the property of the determinant. This page, I don't think this is very important information you need to know, but the following page, yes, that's a property we need to understand for the determinant. Zero rows or column theorem. If matrix A is a square matrix with 2 identical rows, then your matrix determinant A is equal 0. For example, you have the matrix A, they have 2, 2, 2, 2. So when the 2 rows, they are identical. In that case, when you're finding the determinant of A, okay, when you're finding the determinant of A, it will give you a 0. So with this 0 information, that indicate no inverse. So when you have 2 by 2, it's a square matrix. And most of the case, square matrix, it has the inverse. But when you have the two rows, they are identical, then you won't have the inverse. When determinant equals 0, that indicates the square matrix has no inverse.